It is inconclusive because it equals 1. I said that probably wouldn't happen. You know what we probably would have done? As soon as you saw this alternating part, you might have tried something other than the ratio test. Remember, there were no exponents here, no factorials. Down here it's alternating, but guess what? We don't even know what to make of that. So if I would have used the alternating series test, I would have seen that this, not the alternating part, the actual sequence, each successive term gets smaller and the sequence approaches 0. So this would converge, but not by the ratio test. I had to throw 1 in just to see what it would look like. Okay, so part C, it's weird, it's strange. What do we do? Here's what I'm doing. I'm ignoring that -1 because it's an absolute value. It's always going to be positive. Hello. 2, I'm going to take the next term and I'm going to divide it by the original. But dividing by a fraction is the same as multiplying by its reciprocal. I'm going to clean up that factorial and even the term on the bottom. Boy, when I punch all that stuff together, it looks pretty long, but n plus 1 factorial became n factorial times n plus 1. This really just added on 1 extra number on the bottom. And when I look at what's going to divide out, oh my goodness, the n factorial divides out. The 1 times 3 times 5 divides out. Every single number going up to 2n plus 1 divides out. The only thing that is left here is n plus 1 over 2n plus 3. That's it, folks. That's all that's left. And it is the absolute value, but when I look at this limit, I'm going to study the highest degree terms, and what does that equal? I think it equals 1/2. And that's less than 1 for sure. So this is going to converge, not just converging, but it's going to converge absolutely. You know what? Let's see if we can come up with maybe one more example. Final example for this set, ratio test. By the way, before I go, I want to let you know for a lot of these, you can look at it, eyeball it, and use some common sense. Before, we had an example with a factorial and an exponential, which grows faster. Exponentials actually are not as fast growing as factorials. So if you have a factorial over an exponential, that's going to diverge. The number's getting bigger and bigger. If you have an exponential above a factorial, the numbers are approaching 0 faster. Probably going to converge. Well, enough discussion here because I tried to make this confusing. Factorials grow faster, but this is a variable times an exponential. Who's going to win this race? Set it up now on your own and then see if it matches. Don't ask me why, but I actually wrote it out all the way this time. However, remember, I cheat. Dividing by any fraction is the same as multiplying by its reciprocal. Also, know the rules of factorials. If you add 1 on there, you can rewrite it. And the exponentials, e to the n plus 1, is the same as e to the n times e to the 1. Well, ladies and gentlemen, if you haven't figured it out on your own already, that's going to equal 1, that's going to equal 1. We are left with, it looks like, n squared plus n over n plus 1. Oh, wait. Sorry, those cross out. Ha ha. Well, yeah, it looks like we're left with n as n approaches infinity. Really don't think that's going to converge there. I don't know why. Seems to be a little bigger than 1. That's going to probably diverge. So folks, that's what we have. I guess I'll show you one last algebra trick. If you ever have something like n plus 2 to the factorial, you can do that forever. Just know that that is 2 numbers above n factorial. I don't know if that'll help. Maybe you'll come across a problem like that. Who knows? Anyhow, I hope you enjoyed ratio test video.